Hello, it's Radin Wijaya again. Today I'm going to talk about how I make a PHP code that can outperform a C++ code. I know it seems impossible, but this time I will show you how. Okay, let me explain you about what a Fibonacci number is. Fibonacci is an Italian mathematician. It's his name, Fibonacci, and he divides a sequence of numbers from 1, 1, 2, 3, 5, 8, and 13. And it will go to 21 and 21, 34. It's like 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, and so on. And the formula is as follows: when it's function f, when f is 0, it will result in 1, and when f is 1, it will result in also 1. And to make it more interesting, here you come to the recursive part. When fx for anything larger than 1, okay, equals fx minus 1 plus fx minus 2. That's pretty simple. It's pretty much explain it all. And this thing is used to teach computer science students how recursion works. On this page, I'm going to tell you about the two languages that we are using for this video. The one is called PHP. It's known as slow language. It's interpreted language, so it's not compiled, so it doesn't run natively on the machine code. It's built on C, and it's built far from metal, so yeah, it's slow. And the other one is C++. It's one of the highest performing language that this planet has ever seen. It's really fast. It's compiled language, and it's directly run on metal using machine language. And yeah, this thing is used to build PHP. So from here you just can tell how far is the performance metric of C and PHP. That C will be a lot faster, and it's expected. What we are comparing is the execution time of both PHP and C++ codes. We will find the 30 seconds and 40 second Fibonacci number. Why do I choose 30 seconds and 40 seconds? Simple, because the 30 second and 40 second will take a while to find. However, it's not too long for us to wait. And both of code will employ recursion. No iteration, definitely. On the screen you can see that both PHP and C++ functions are remarkably similar. You can see that they are both using ternary operation, and both are recursive in two ways, so it will have two roots for each iteration of recursion, and from there you can see that they are approximately as intensive in terms of computational complexity. Let me explain you about the Fibonacci function. It's pretty much straightforward. At first we have to check whether x is less than 1. I use ternary checking here, so if x is less than 1, it will result in 1. However, if it's other than 1, it will resort to calling recursively the function as x minus 1, x minus 2. And this time is to log the time, how long the function takes to finish. And now we'll try to run it with Fibonacci of 32. This function will take quite a while to finish, and don't worry, it's normal because the calculation is massive. They are calculating too many things, and it's done in 4.4 seconds, 4.4 million microseconds. Now let's go to the C. The function writes exactly the same. Okay, just I use the same PHP logic in the C, so it should perform the same in computationally. And let me compile it. Done. And a.out is the output file of the standard G++. I haven't had time to make file, and it was very fast. The result is the same, but it's done in 18,000 microseconds. It's around 0.018 seconds. It's in a blink of an eye. Done. Okay, cool. Now let's continue to the PHP optimized file. This time we use cache, and I use no coalescing operator, and with the ternary it's possible. Yeah, I do it because to make it done in two lines. One is for the case and the other is for the ternary. Okay, done. It's done in 56 microseconds. It's very fast. It's a lot faster compared to the C because the number of iteration is way less. Okay, it's linear. Now let me show you what happened when we use to find the 40 seconds of Fibonacci number. For example, now we are doing it with C++, Fibonacci 42 and with PHP Fibonacci 42. Why 42? Because 45 will take too long, and 42 is just nice because, but I will remove the timing here. Okay, compile it and run. Okay, around 2 seconds perhaps, give or take a few microseconds. And then for the PHP, we'll try 76 microseconds. That's very fast. And as you can see, it's linear from 56 to 76, from 32 to 42, just like it's not exponential time. I can tell you by hand that the recursion of Fibonacci 5 will call Fibonacci 3 and Fibonacci 4. Okay, from here, Fibonacci 3 will call Fibonacci 2 and 1, and Fibonacci 2 will call Fibonacci 1 and 0, and Fibonacci 4 will call Fibonacci 3 and Fibonacci 2. Okay, and then for Fibonacci 3 will call Fibonacci 2 and 1, and then from Fibonacci 2 will call 1 and 0, and on the last Fibonacci 2 will call Fibonacci 1 and 0. From here, it's easy to see that they are making repetitive calculation, and that is wasting a lot of time and wasting a lot of resources. We must cut it. What we learned from this video is that C++ is actually a lot faster than PHP using the same algorithm, and what makes it slow is actually that we force the computer to make a lot of unnecessary calculations, so the complexity is OX squared. So yeah, it's very inefficient, and that finding the 100 Fibonacci number will take maybe hundreds of years. And those slides concludes too, when the data is small, it's the algorithm that limits the performance. It's not the programming language or the computer. We are not in the 80s, and modern programming language and computer is very fast, they are well optimized. And what I did to the PHP code is adding a simple cache, essentially turning the recursions into almost iteration complexity. And you know what? Actually, the iteration version of Fibonacci is called dynamic programming, and I essentially made recursive dynamic programming. So that I hope that you like my video. Don't forget to like and subscribe. Thank you. Information of the platform used is Ryzen 3 2200. It's running Fedora 31 native, not VM. It's the C compiler is GNUC, and the PHP version is PHP 7.3.